Hey everyone, and welcome to today's Explainer. We're jumping right in because today we're unlocking the secret to measuring the 3D world around us. I mean, just think about the room you're sitting in right now, the buildings outside your window, or even just the stuff on your desk. Our world is not flat, and it certainly isn't made up of just one basic shape, right? So today we're going to learn how to master the dimensions of our reality by doing something called summing the solids. So here's a question for you. How exactly do you calculate the volume of a rocket ship blasting off into space? Or let's say an ice cream cone melting on a hot summer day? Now, if you flip through a standard geometry book, you'll find formulas for perfect spheres, perfect cylinders, and perfect cones. But let's be real. Everyday objects aren't just simple textbook shapes, are they? No way. They're actually these fascinating, complex combinations of them. Section 1. The big idea, composite volume. Okay, let's dive into this. When you hear the word composite, I really want you to think of a team, or a combination, kind of like a masterpiece made from a bunch of different materials. This is the absolute core concept of the TEKS 8.6a standard. So what are composite solids? Well, they're simply 3D objects made by stacking, joining, or even cutting basic shapes like cylinders, cones, and spheres. You see, the most complicated problems in the world are often just a bunch of simple problems stacked together. It's like a giant puzzle. A rocket isn't some impossible, crazy shape. It's literally just a cylinder with a cone sitting right on top. And here is the secret sauce. Just break it down. You calculate each piece, and then you add or subtract them. Guys, it is truly that simple. You absolutely don't need a magic formula for a rocket ship. You just need to deconstruct the object, do the math for the cylinder, do the math for the cone, and combine them. You are already equipped with everything you need to do this whole shebang. Moving on to Section 2, building the ice cream cone, our first real-world example. Let's take this part-to-whole method and apply it immediately to something delicious. Just picture a perfectly round scoop of ice cream sitting right on top of a classic sugar cone. All right, let's walk through the math step by step. Step 1, we look at the cone. Let's say it has a radius of 3 centimeters and a height of 10 centimeters. Our formula is 1/3 times pi times radius squared times height. So 1/3 times pi times 9 times 10. Well, that gives us 30 pi, which is roughly 94.25. Step 2, we look at the ice cream scoop, which is a sphere. It also has a radius of 3 centimeters. Now, the sphere formula is 4/3 times pi times radius cubed. That's 4/3 times pi times 27, which gives us 36 pi, or about 113.10. See what we did? These two formulas give us two distinct pieces of the puzzle. And step 3, just add them together. And boom, just like that, we get 207.35 cubic centimeters. What totally seemed like an intimidating shape at first becomes entirely manageable just by breaking it into two pieces. That's the final combined volume of our ice cream cone, and it beautifully illustrates the power of composite math. Section 3, stacking up the snowman. Real-world example 2. Now, I want you to shift gears and imagine a winter wonderland. Picture building a snowman, packing the snow tight, and rolling it up piece by piece. You know, a snowman is actually beautifully simple when you look at it through the eyes of geometry. It's really just 3 spheres stacked on top of each other. Let's say the bottom sphere has a radius of 3 inches, the middle has a radius of 2 inches, and that top one has a radius of 1 inch. To find the volume, we just use our trusty sphere formula, 4/3 pi r cubed, for all 3. We cube the radius first, right? So 3 cubed is 27, 2 cubed is 8, and 1 cubed is just 1. If we add those cubed numbers up, 27 plus 8 plus 1, we get 36. Now we just multiply that by 4/3 pi to get the total spherical volume, which comes out to 150.80 cubic inches. Honestly, it's absolutely fascinating how training our brains to see simple shapes hidden inside complex ones completely changes how we view the world. We're looking past the coal eyes and the carrot nose, and we are seeing the underlying math. How cool is that? Okay, Section 4, constructing the dome, real-world example 3. Let's step away from treats and snowmen and look at some heavy architecture. Think of a grand Capitol building, or maybe an observatory. You've got a cylindrical dais topped by a hemispherical dome. Let's deconstruct this grand building together. Step 1, we calculate the cylinder base. Say it has a radius of 4 meters and a massive height of 10 meters. The cylinder volume is pi times radius squared times height. So pi times 16 times 10 gives us 160 pi, which is about 502.65. Now, step 2, and here's where we have to be super sharp, we have a dome on top. A dome isn't a full sphere, right? It's a half sphere or a hemisphere. So we take our regular sphere formula, 4/3 pi r cubed, and we just multiply it by half. Half of 4/3 pi times 4 cubed gives us 2/3 pi times 64, which comes out to roughly 134.04. Step 3, we just combine our cylinder base and our half-sphere dome. And that gives us a massive 636.69 cubic meters. It's kind of mind-blowing to realize that we can calculate the volume of huge architectural marvels using the exact same logic we just used for a melting ice cream cone. Once you grasp this concept of composite volume, the scale of the object doesn't matter at all. All right, section 5, ready for the homework? Test your knowledge. Let's see how we can put these new tools to the test with some practice problems you might actually see. So, looking at our list, we've got a cone and hemisphere joined together, a tank with a cylindrical base and a half-sphere top, a rocket ship shaped like a cylinder and a cone, a sculpture made of 2 stacked spheres, and finally a container made of a cylinder and a dome top. Notice the pattern? Every single one of these problems is exactly what we just practiced. The rocket, the tank, the sculpture, they are not impossible math problems. They are literally just simple shapes waiting to be broken down. You've definitely got the tools to handle these now. Section 6, Education, Morality, and Peace, the ultimate building blocks. Now, before we wrap up today's explainer, let's take this idea of building blocks and use it to bridge into a profoundly important concept from the heroesmartacademy Godly Learners series. We spent all this time talking about how to build physical objects piece by piece, but what about the building blocks of a person? Because just like a 3D object needs the right pieces to take a solid shape, so does a successful life. When we deconstruct human success the exact same way we just deconstructed those 3D shapes, the source material points out 2 very different foundations. On the one hand, education without morality is viewed as a broken formula. Think about it. What is the point of being highly educated if a person continues to make bad choices that end up hurting themselves and the people around them? Being smart just isn't enough on its own. On the other hand, the series presents a much stronger formula: education with biblical morality. The idea here is that when you combine knowledge with a solid moral foundation, you're actually building a structure for a genuinely good and impactful life. And that brings us to a final thought for today. The text cites Romans 8:6-7, which promises peace of mind to everyone who keeps their minds spiritual. It's a recurring theme we see as people engage with this content. Because just like adding that final geometric shape completes the volume of a composite solid, keeping your mind anchored spiritually is seen as the ultimate piece added to the equation of life, ensuring true peace of mind. So as you go out there to calculate the shapes of the real world, what foundational building blocks will you choose to stack in your own life?